Welcome, geometry students, to the homework help video. Please look and make sure that you are on the correct assignment. And if this is the assignment that you are on, let's go ahead and continue on. Let's take a look at the first problem, number 1. The directions for numbers 1 and 3 state, identify any symmetry of the figure. Now, let me explain something to you. On a test or a quiz, I'm not going to ask you to give me every single line of symmetry there is. I mean, my goodness, take a look at this. You could draw a line right here, and there's a line of symmetry. If you folded this over on top of this side, here's a line of symmetry, here's a line of symmetry. There's all kinds of different lines of symmetry. Okay, the main thing I would ask you is draw me a line of symmetry. And so you could draw a line here. That would be a line of symmetry. Or I might ask you, does this figure have horizontal line symmetry? So you would draw a horizontal line and you would see, does it have horizontal line symmetry? Well, obviously it does. If you were to fold this figure at this red line on top of this side over here, this side right here would fall right on top of this side over here. So the answer would be yes. Now, what about rotational symmetry? Well, I've taught you how to do this, and I hope that you've listened to me. The best way to do rotational symmetry is to copy the figure onto a sheet of paper and then start to turn the figure. You can turn the sheet of paper, okay? And whenever this figure over here looks exactly like this one over here, then you know you have rotational symmetry. So we start rotating it, and look, right there. That looks like the original figure that we started off with. Now, if I had rotated, please listen to me carefully, if I had rotated this figure from here, sorry about that, if I had rotated the figure from here all the way to here, that's 90 degrees. That's so obvious. From here to here is 90. So half of 90 is 45. So if I went from here to here, that's 45. Well, I went a little bit past that to about right there, and I'm just going to guess that's about 60 degrees. I'm just guessing. So I would say that I have rotational symmetry at 60 degrees. Now let's continue on. Let's keep turning it, turning it, turning it, turning it. Ooh, look right there. Look right there. That totally matches this figure over here. So now how far did I go? Well, right here, if I would have been here, that would have been 90, and I'm about right here. And I would say that's probably, I don't know, 120, probably 90 plus 30 more degrees. But again, I'm just estimating. And you could continue on and see there's rotational symmetry again right there at 180 degrees. And so that's all that I wanted you to do on these types of problems. Let's take a look at number 3. Same thing, students. I mean, I don't want you to list out every line of symmetry there is. Obviously, we have a horizontal line of symmetry. I didn't draw a very good line, but you see my point. And obviously, we have a vertical line of symmetry. Okay? Now, how about rotational symmetry? Well, let's take a look and let's see real quick. The best thing to do is to copy this onto your sheet of paper, and then take the sheet of paper and rotate the sheet of paper like this. Let me get this out of the way. Let's go up like this, and we'll go like this. And here we go. I'm going to rotate it. And when it looks like the exact same figure above, I'll stop right there. So I rotated 180 degrees. So we have rotational symmetry at 180 degrees. And we also had vertical line symmetry or horizontal line symmetry, and we also had vertical line symmetry. Okay, moving on. The next number I want you to do is number 5, and number 5 simply says find the midpoint between these 2 points. So I'm going to go very quickly. The formula is x plus x, that's 3 plus 5, divided by 2, comma, and the formula also says y plus y divided by 2. This is your x, this is your y, this is your x, this is your y. Well, over here in this fraction, 3 plus 5 is 8, 8 divided by 2 is 4. Over here, negative 2 plus 12 is 10, 10 divided by 2 is 5. So the midpoint that lies right in between these 2 points up here is 4, 5. Let's take a look at number 6. LM. Segment LM has a length of 11. What is the length of LN? Now, I did forget to do one thing. I forgot to read the directions to you. And the directions say N is the midpoint of LM. So we're going to say L is right here. We're going to say M is right here, okay? And N is the midpoint. That means it's right in the middle of those 2 points. Now, LM has a length of 11. So from here all the way over to here, the entire length of this segment that I'm scribbling on is 11, okay? Now they're asking us to find the length of LN just from here to here. Well, students, aren't you just cutting 11 in half? Well, sure you are. So 11 divided by 2 would be 5.5, or you're also welcome to say 5.5, okay? 5.5 or 5.5. Pretty simple. All right, number 7. Same thing. We have our segment here. Here's L, here's M, here's N. Now I'm going to quickly copy this to save time, so I won't keep drawing this over and over. Okay, there we go. All right, moving on. Now it tells us NM has a length of 11. So here's segment NM. So this little segment here that I've kind of put a squiggly line on here has a length of 11. Now they're asking us to find the length of LM. So they want to know the whole length from L all the way to M. Well, look, students, if N is right in the middle, that means from here to here is 11, but it also means from here to here is also 11, so the total length all the way across would be 22. 11 times 2, or 11 plus 11. Okay, let's take a look at number 8. Now, number 8 says LN has a length of 11. So I'm going to go from L to N right here. Don't forget N is your midpoint. And I'm going to put 11. And then it says, what is the length of NM? So I'm going to change colors. They want to know the length from N over to M, the segment in blue. Well, students, the answer is obviously 11, because if N is right in the middle and from here to here is 11, then from here to here is also 11. So the answer would be 11. Okay, moving on now to number 9. Numbers 9 and 11, the directions say to identify any symmetry. So once again, this is kind of a repeat of numbers 1 and 3, so I'll go pretty fast here on these. Obviously, there is no way I have a vertical line of symmetry. There is nowhere I can draw a vertical line that if I fold the object on the line that I've drawn, that the two sides will be a mirror image of each other. However, there is a horizontal line of symmetry, and I'm probably not drawing that very well. Maybe I can move it around a little bit, but there it is. So there's your horizontal line of symmetry. If I were to take this figure and fold it in half right on top of this line, this side over here would fall right on top of this side over here. So I have horizontal line symmetry. And then as for rotational symmetry, I'm not going to spend a lot of time on this, but very quickly, I'm going to take this figure here and I'm going to start turning it. And anytime that it looks exactly like this one over here, then I will call that rotational symmetry. Well, doesn't look like it yet, doesn't look like it yet, nope, not yet, nope, nope, and there. I went 180 degrees. I went from here to all the way down to the bottom. That's a half a circle. So you only rotate 180 degrees and you stop. You don't go any further. And nowhere during this rotation did this figure ever look exactly like this figure over here. The only way you could get it to look just like this figure over here is to rotate 360 degrees, and that's basically a joke because you're just back to where you started with at the beginning. So, okay, number 11. Let me get a drink here real quick. Okay, number 11, same thing. There's a lot of lines of symmetry. I do not expect you to draw every single one. You could draw one here, a horizontal line. There's a line of symmetry. You could draw one here. That's a vertical line of symmetry. You could draw a diagonal line of symmetry right here. You could draw another diagonal line of symmetry right here. There's quite a few lines, okay? Now, rotational symmetry, I believe there's quite a few. So let's see. Let's pull this over here and let's start turning it, and we'll stop it when it looks exactly like this figure over here. So here we go, and it looks like I'm going to hit. Now remember, when I go from the first dot to here, that's 45 degrees. So I go a little further, and there it is. I would call that 60 degrees. Okay, so I'm going to write 60 degrees, And now let's continue on. All right. Now remember when I hit here, there's 90, and then I'm going to keep going. There it is. So it looks like I went 90 plus probably about, I don't know, 30 more. I'm just guessing. You can estimate. That's totally fine. And that would be 120 degrees. And then very quickly, let's continue on. It looks like when I hit 180, yep, 180 degrees, this object here matches this object over here exactly. So there we go. We have rotational symmetry at 60 degrees, 120 degrees, and 180 degrees. All right, let's move on. Let's take a look at numbers 13 through 16. Now the directions for 13 through 16 read as follows. They want you to copy these figures on a separate sheet of paper. You do not have to do that. You are more than welcome to very lightly take a pencil in your book and draw a line here and draw a line here, as long as you erase them when you're done. So they want you to draw segments AC and BD. That's the first thing they want you to do in the directions. And then they want you to find the midpoint of those two lines, and then see if the two midpoints are the same. So let me show you how to do this, okay? The first thing they want you to do is draw AC and BD. So here's AC, there we go, and here's BD. Now, I'm going to put this, I'm going to put midpoint of AC. Midpoint of AC. Well, do you see this letter A right here? What's the ordered pair? 1, 1. And do you see the letter C right here? What's the ordered pair? Well, it looks like it's over 6 and up 4. So the ordered pair for C is 6, 4. So A is 1, 1. C is 6, 4. So the midpoint would be X plus X divided by 2, comma, Y plus Y, 1 plus 4 divided by 2. And so if you simplify that, you will get 3 1/2, comma, 2 1/2. Now I want to be kind to you students, but you also have to come to the point to realize you're juniors in high school now and you're in track too. So I should not have to explain to you how I go from here to 3 1/2 or from here to 2 1/2. Okay, but it's really simple. I mean, it's 1 plus 6 is 7. 7 divided by 2 is 3.5 or 3 1/2. 1 plus 4 is 5, and 5 divided by 2 is 2 1/2. So the midpoint of AC will be this right here. All right. Now I want us to find the, I guess I got to put MDPT, the midpoint of BC. Well, here we go. Let's see. I'm going to put a right here and a C right here. The point for B, and I think it would be wise to quickly change colors. The point for B would be 1, 4. And the point for D would be 6, 1. Okay, so we're going to find the midpoint between those 2 points. So we would have X plus X, that's 1 plus 6 divided by 2, comma, Y plus Y, that's 4 plus 1 divided by 2. And look what you get, the exact same thing. 7 over 2, which is 3 1/2, and 5 over 2, which is 2 1/2. So there we go. There's the answer. So we found the midpoint of both segments. And are they the same? The answer is yes, they're the same. Let's try another one, number 14. Okay, here we go. We're going to use the color blue here, and we are going to just spill water on my Mimeo pad, so hold on 1 second here. All right, here we go. Let's go ahead and draw this segment here, AC, and I guess we'll go ahead and use red for that. And so we're going to find the midpoint of AC. Now point A looks like -1, -3. And point C looks like we're over 2 and up 2, so 2, 2. That's point C. So the midpoint would be -1 plus 2 divided by 2, comma, -3 plus 2 divided by 2. So we would get 1/2, 1 over 2, and -1/2. -3 plus 2 is a -1. So there's the midpoint of AC. All right, make sure I'm right on that. And actually, let me check my work real quick here. And students, I apologize. I did make a mistake right here with this -3, and that'll happen sometimes this year. that ordered pair right there should have been -1, -2, and so this should be a -2 right here, and I apologize. So -2 plus 2 is 0, and 0 over 2 is going to give you a 0. Okay, so there's the midpoint for AC. I'm going to put midpoint equals 1/2 0. And now let's take a look at BD, and we'll change the color here real quick. We'll go with blue. So now we're looking at segment BD, and so let's see what we have here. It looks like point B would be -2, +2, so -2, comma 2, and it looks like point D would be over 3 and down 2, so over 3 and -2. Now let's go ahead and find the midpoint. It would be x plus x, -2 plus 3 over 2, and then y plus y, -2 plus a -2. Excuse me, that would be a +2 right here. So a +2 plus a -2 all over 2, and that again would give you 1/2, comma, and 2 plus -2 is 0. 0 over 2 is 0. So there's the midpoint. So the midpoint of BD is also 1/2 0. So the answer is yes, the midpoints are the same. Okay, so pretty simple. 2 more and we're finally done. Okay, let's take a look now very quickly at segment AC. Now, can I show you something that really saves you time here, students? And please learn to take shortcuts like this. Okay, I'm going to go ahead and use a red line instead. Now watch this please, students. Okay, look, let's draw AC. Does everybody see how AC is a perfectly vertical line? Do you see that? So why would I, if it's a perfectly vertical line, can I not just count over and find the midpoint? Well, the answer is yes. I mean, look, it's a perfectly horizontal, I think I said vertical, and I apologize. It's a perfectly horizontal line. Look at that. It's straight across. Now you could find the point of A and find the ordered pair of C and use your midpoint formula, and that's fine, but it's a long way to do it. My suggestion is to see that you have a perfectly horizontal line, and so right here is your midpoint, right in the middle. I mean, look, count the spaces. From here to here is 1 space, 2 spaces, and over here is 2 spaces. This is right in the middle. And so it looks like the midpoint of AC equals, let's see, +1, -1. So +1, -1. Okay, now let's find the midpoint of BD. And it looks like to me, I mean, if we just take our time here and do this carefully, we have the same scenario. Instead of having a perfectly horizontal line, we have a perfectly vertical line. And so we can easily see this point right here is in the middle. I mean, start here and count down 1, 2, 3 spaces, then count here and count up 3. 1, 2, 3. This point's right in the middle. So the midpoint of BD would also be 1, comma, -1. So did they have the same midpoint? Yes, they did. Definitely. Okay, number 16. I wish they could all be that easily, but excuse me, but they're not going to be. Okay, let's take a look at segment AC. So here's segment AC, and let's go ahead and find the midpoint of AC. It looks like point A is going to be 1, comma 1, and it looks like point C is going to be over 3 and up 4. So 3, comma 4. Well, let's find the midpoint. X plus x is 1 plus 3 over 2, comma, y plus y is 1 plus 4 over 2, and of course 1 plus 3 is 4 divided by 2 is 2, and 5 divided by 2 is 2.5 or 2.5. So the midpoint of AC would be 2, comma 2.5. Now let's find the midpoint of BD. So here is the segment BD. It starts here and it comes down to here. And that's pretty much a non-straight line. Let's try that again. There we go. And let's see. Point B would be over 1 and up 4. So 1, comma 4. By the way, if you're wondering, Mr. Earhart, why do you not just count over like you did in the last problem here? Well, students, in the last problem, we were dealing with perfectly horizontal lines or perfectly vertical lines, and in this problem we're not. These are slanted diagonal lines, so we have to use the midpoint formula. Okay, point D would be over 5 and up 1, so 5, comma 1. So here we go. The midpoint would be x plus x, that's 1 plus 5 divided by 2, comma, y plus y would be 4 plus 1 divided by 2. So the midpoint would be 6 divided by 2 would be 3, and 4 plus 1 is 5. 5 divided by 2 would be 2.5. So the midpoint of BD would be 3, comma, 2.5. Now, are the two midpoints the same? No, they are not. Absolutely not. They are different ordered pairs. So that's a lot of practice in simply taking two ordered pairs and finding the midpoint, okay? All right, moving on to number 17. Let's see, what do we have? 17, 19, and 20. The directions for 17 and 19 and 20 read as follows. Please, students, listen to me carefully. Let R be the midpoint of ST. Let R be the midpoint of ST. Let's go ahead and draw that and label it. Let R be the midpoint of ST. So here's S, here's T, and let's put R right in the middle. And then let me copy this so we have it for our other two problems that we're going to do. Okay, and here we go. All right, so the directions state that R is the midpoint of segment ST, or in other words, R is in the middle of segment ST. Now, SR has a length of 6, so from here to here, the segment that I've highlighted has a length of 6, and they want to know what is the length of RT, and that of course would be the segment from R over to T. Well, the answer is obviously 6, because if R is in the middle, then if from here to here is 6, also from R to T is a 6, so the answer to 17 would be 6. So what is the length of RT? 6. Okay, moving on to number 19. That's a pretty simple problem. Okay, number 19. ST has a length of 3/2. What is the length of SR? Now let's think about this. We're not going to panic because we see fractions, okay? We're fine with that. The length of ST is 3/2. So from S all the way over to T, this entire thing has a length of 3/2. Do we see that okay? Now, they want you to find the length of SR, which is from here to here. We'll put a little X there. So the entire length from S all the way to T is 3/2, and they want you to find basically half of that because R is in the middle. So we're going to find half of 3/2. Now there's many ways to do that. We're going to take, one way to do it is to take 3/2, which is the entire length from S to T, and simply divide it by 2. Now you can use your calculators if you're weak with your fractions. Somewhere by now, after 2 years of high school math, or for some of you 1 year of high school math, you should be able to find the fraction button on your calculator. If you don't know how to do that, you can see a student or someone, they'll help you find that. So if you have an ABC button or a fraction button, you can simply type into your calculator 3/2 divided by 2. Now if you don't have one, you can still solve this relatively quickly. You should remember from middle school and elementary school, when you're dividing fractions, you first of all put this over 1, so you have 2 fractions. Next, you change the division sign to a multiplication sign, and you flip the fraction. So 2 over 1 is 1 over 2, and now you go ahead and multiply, and you will get 3/4, because 3 times 1 is 3, and 2 times 2 is 4. So if the entire length from S to T is 3/2, then the length from S to R is 3/4. Okay? All right, moving on to number 20. This will be a good problem for y'all to think about. Let's see if we can figure this out, okay? Let Q, now they're introducing a new letter to us, okay? Let Q be the midpoint of SR. So I'm going to go ahead and put Q right here, right in the middle of SR. Now be careful here. QR has a length of 3. Now, students, would you please listen to me? I'm going to highlight QR, and I'm going to put a 3 right here, okay? Now let's pause, and I'm going to forget the problem. I just want to fill in some numbers real quick. Is that okay with you guys? Look, if QR is 3 and Q is the midpoint between S and R, then I also know from S to Q is also 3. Does that make sense? It should, because it says right here Q is the midpoint of SR. Okay? Now, if SQ is 3 and QR is 3, then doesn't it make sense that the length from S to R is what? 6. SR is 6. 3 plus 3. Well, now hold it. We know from the directions that R is the midpoint of ST. So if R is right in the middle of ST, that means if SR is 6, then RT is also 6. Now that we've filled all that in, let's see what they're looking for. What is the length of ST? So they want the entire length of this segment from S all the way over to T. Well, SR is 6 and RT is 6, so ST would very simply be 12. Not too difficult, students. Really, it's not, okay, if you think it through. Okay, now we're going to look at numbers 21 and 23. Now, 21 and 23 are interesting. They're very deep thinking problems, and probably most of you had some questions on these, so that's totally fine. And if you'll listen carefully, I think I can help you on these, okay? All right, they want you to draw. They want you to fill in circles so that you give them what they're asking for. And number 21, they're asking for a figure that has a vertical line of symmetry but no horizontal line of symmetry, and also no rotational symmetry. Well, there's more than one answer. First of all, please understand that, okay? And secondly, I'm not going to color these in. That would take me a ton of time to color each circle in, so I'm going to use X's, okay? So see if this works. There's more than one answer, and I really can't say here's how you do it, step 1, step 2, step 3, step 4. You just got to think outside the box, okay? You just got to think of shading in circles. There's your figure. Now, I have a question for you. Do we have a vertical line of symmetry? Well, let's find out. Let's draw a vertical line right down the middle. And that's not a good line. Let's draw a vertical line right down the middle, and let's move it over so it's actually in the middle. And did not want to do that. There we go. Yeah, perfect. Look, your figure looks like this. That's what your figure looks like. That's what it means when I colored in these X's. There's your figure. Okay, do you see that okay? Now, if I were to fold this piece of paper in half right on top of this red line, all of these X's right here would fall right on top of these X's over here. So we definitely have vertical line symmetry, but we're supposed to have no horizontal line symmetry. Well, let's see. Let's draw a horizontal line. Here's a horizontal line. Hey, we're good. We do not have horizontal line symmetry. You say we don't? No, not at all. Look, if you were to fold this piece of paper over right on top of this side over here, fold it right on the red line, look at these X's here. These X's right here, these 3 X's, would not fall on 3 X's over here. We do not have horizontal line symmetry. And you know what else we don't have? We do not have rotational symmetry, and I'm going to prove that to you right now if you'll just watch carefully. I'm going to shrink this down so we have a little room, okay? And then put it right over here. Now watch. As I take this figure and turn it, it will not look like the original figure at all, ever. Turning it, turning it, turning it, turning it. There, I went 180 degrees, and never in any of my rotations did it look like the original figure over here. Never. Okay? So it does not have rotational symmetry. Now, Mr. Earhart, how did you know to do this? Well, it's just, there's really no steps. You have to kind of just try different things. You have to think outside the box. And you have to say to yourself, okay, let me get this thing back up here. There we go. You have to say, okay, I'm going to try putting, X's here and here, and just try different things. And then as you try each idea that you have, test it and see. Did you have a vertical line of symmetry? You were supposed to. Did you have a horizontal line of symmetry? You weren't supposed to. Did you have any rotational symmetry? You weren't supposed to. Okay? I hope that helps. Number 23. They want us to have a vertical line of symmetry and a horizontal line of symmetry. Well, students, there are many answers to this, okay? I'm just going to draw a figure like this. I'm just going to make a rectangle. A rectangle works. There we go. I mean, if I were to draw a vertical line right through here, and I know it's not the best vertical line, but you get the idea, and fold this thing right over on top of this side over here, everything would fall right on top of all of these x's here would fall right on top of x's over here. And if I were to draw a horizontal line right here, I've got symmetry again. If I were to fold this like it was a piece of paper and fold it right on the red line, all of these x's over here would fall right on top of the x's over here. It would be perfect. And there's definitely more than one answer, okay? Just two more problems and we're finally done. So here we go. They want us to draw in numbers 25 and 26, they want us to draw on a coordinate plane the following. For number 25, they want us to draw a triangle that has y-axis symmetry but does not have x-axis symmetry. So let's see if we can do this, okay? There's my y-axis and there's my x-axis. Let's go ahead and label this. Here's y and here's x. Now I'm gonna hedge a little bit. In the directions it said label each vertex or corner with its coordinates. I'm not going to make you do that, but I do want you to draw a triangle that has y-axis symmetry but not x-axis symmetry, okay? And that's really going to be pretty simple to do. I don't want you to feel dumb or anything, but it's really simple. I mean, you want to draw a figure that's on the y-axis in which the y-axis cuts the figure in half, okay? But you want to do it in such a way that the x-axis does not cut it in half. So look at that triangle that I just drew. If you were to fold this triangle right on this y-axis, would not this side of the triangle here fall right on top of this side over here? Sure it would. So we have what we call vertical line symmetry, or in this case we call it y-axis symmetry because this is the y-axis. Now, do we have x-axis symmetry, or in other words, do we have horizontal line symmetry? Well, no. If you were to fold this triangle right on this black line, there's no way this space right here of the triangle would fall right on top of this space over here. So this picture that I've drawn is a picture that satisfies what they want us to do. Now, is there more than one picture you could draw? Absolutely, but this is one of them, okay? Moving on to number 27. They want us to draw a quadrilateral that has both y-axis symmetry and x-axis symmetry. Now, first of all, let's draw our coordinate plane. So there's my y-axis and there's my x-axis. And then secondly, now that we've done that, let's go ahead and ask ourselves, what is a quadrilateral? Because they want us to draw one. Well, a quadrilateral is any four-sided polygon, okay? A four-sided polygon. So they want us to draw a four-sided polygon that has both y-axis symmetry and x-axis symmetry. Well, students, a rectangle with its center right here at the origin, or a square with its center right at the origin, all of those would work. For example, here's a rectangle, and notice how, for the most part, it's not perfect. Let me slide over a little bit. There we go. For the most part, my center of the rectangle is right here. So there we go. I have y-axis and x-axis symmetry. Let me prove that to you, okay? If I were to fold this rectangle right on that black line, would not this part of the rectangle here fall right on top of this part over here? Sure it would. And if I were to draw a vertical line right here, which is the y-axis, and I were to fold this rectangle right on the black line, would not this side of the rectangle over here fall right on this side over here? Sure it would. So I have y-axis symmetry, or we call it vertical line symmetry, same thing. And so we satisfied the description. They wanted us to draw a quadrilateral that had both y-axis and x-axis symmetry, and we've done that, okay? So very good. Okay, I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.